Okay, let's learn some other techniques which will help us find derivatives of more complicated looking functions. Today we're going to focus on the product rule and the quotient rule. And let's start with the product rule. If we have a function p of x which can be written as the product of two other functions, let's call them u of x and v of x, then p prime of x, or the derivative of p, is going to equal the derivative of the u function times v plus the u function times the derivative of the v function. A shorter way of writing that would be p prime of x is going to equal u prime v plus uv prime. So in other words, when you have the product of two functions and you want the derivative, you're going to take the derivative of the first one times the second plus the first function times the derivative of the second. Before I get into and this is referred to as the product rule. So let's look at a couple examples with this, and then we'll get into the quotient rule. Find y prime for y equal x squared times the square root of x minus 8. So the first thing you look at and say, is there any way we can simplify this? And well, the answer to that is really no. So now I want to think of this as two functions multiplied together. So that u of x function, I'm looking at the x squared and thinking that's one of the functions. And then the other function, v of x, is the square root of x minus 8. Or another way of writing that would be x minus 8 to the 1/2 power. Okay, so according to this rule, y prime is going to equal u prime v plus uv prime. So, and you don't really need to write it over on the side, but it might help the first few times you do it. So the derivative of u with respect to x is just going to be 2x. The derivative of v with respect to x is going to be 1/2 x minus 8 to the negative 1/2 power. I'm using the power rule there. Or another way of writing that, we could write it as 1 over 2 times the square root of x minus 8. So now let's apply that to this problem. So u prime is 2x times v, v was the square root of x minus 8, plus u, which is x squared, times v prime, which was 1 over 2 times the square root of x minus 8. And, there's several ways we could write that, but I think since I'm using the square root in the first one, I think I'll probably write the second one as a fraction and 2 square root x minus 8. If you want to write it with fractional exponents instead of radicals, that's fine, but they're all equivalent. All right, let's try another one. And maybe it would be a good idea to pause and go ahead and try and work this one out first, and then see how you did. All right, so once again, dy dx, or y prime, or the derivative of y with respect to x. So my u function is x cubed, and my v function is 1 minus 3x quantity squared. Now to do this, there's a technique that we want to apply called the chain rule, but we haven't worked with that yet. So an alternative to trying to do that would be, well, I can multiply all this out. So that would be x to the third, and if I square 1 minus 3x, I'm going to get 1 minus 6x plus 9x squared. And then if I distribute the x cubed, I get x cubed minus 6x to the fourth plus 9x to the fifth. And so dy dx, now I can just use the power rule, and I'll put it in descending order. So it's going to be 45x to the fourth minus 24x to the third plus 3x to the second. And I'd save myself some time by simplifying instead of trying to use one of the rules just to use one of the rules. Now the other useful rule is called the quotient rule. And so let's take a look at that. And so if we have a function q of x which is equal to u of x over v of x, and obviously v of x is not 0, then we get this, and we could actually derive this from the product rule if we like. But q of x is going to equal u prime v minus uv prime all over v squared. So in other words, you take, for your numerator, it's almost like the product rule except it's a subtraction. The derivative of the first times the second minus the first times the derivative of the second, and then all of that is over the second function squared. So this is the quotient rule, and let's go ahead and apply that to an example. Okay, so in this case, we have that u will be the x squared. And notice now, and this is where students make a mistake sometimes, is v is not equal to 1 over 2x plus 3. It's just equal to the 2x plus 3. That's important. So the derivative of u with respect to x is going to be 2x, and the derivative of v is going to equal just 2. So let's calculate dy dx. The rule said that it's going to be u prime times v minus uv prime over v squared. So, and I wrote, by the way, I don't want to confuse you, we'll be coming up with that a little bit later. Let's say du dx. And this will be dv dx. And the shorthand would be u prime and v prime. So the derivative of u is going to be 2x times the second function, which is 2x plus 3, so I'll put that in parentheses, minus the first function, which is x squared, times the derivative of the second function, which is 2, all over the second function squared, so 2x plus 3 squared. Now we can clean this up a little bit. If I distribute in the numerator and combine like terms, I'm going to have a 4x squared minus 2x squared gives me a 2x squared plus 6x over 2x plus 3 quantity squared. Now, could you factor an x out of the numerator? Yes, but that's not going to help you cancel anything, will it? But what if we factored out a 2x in the numerator? And then we're left with what? X plus 3. But that still won't help us cancel anything in the denominator. So either form would be correct, but really no need to do extra work to factor unless you can cancel something. All right, let's try one last example. So here, my top function is the square root of x, and my bottom function is x squared plus 1. So u prime is equal to 1 over 2 root x, or 1/2 x to the negative 1/2 power, and v prime is equal to 2x. So y prime is going to equal the derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom squared. And so then I guess we could distribute and try and simplify a little bit. So what do you have? You have 1/2, and then you have x to the 1/2 times x squared. We can simplify that. I'm sorry, negative 1/2. And then plus, and then we would have 1/2 x to the negative 1/2 times 1. And then minus, let's just leave it in the order that it's showing, x to the 1/2 times 2x. And sometimes you have to play around with it if you don't see it ahead of time. So if I simplify this, what am I going to get? I'm going to get 1/2, and then x to the negative 1/2 times x to the second gives me x to the 3/2 power, plus, and then I'm going to have 1/2 x to the negative 1/2 power, and then minus, and then I'm going to have 2 x to the 1/2 times x to the first gives me x to the 3/2. So I have some like terms there I can combine, all over x squared plus 1 quantity squared. So I have 1/2 x to the 3/2 minus 2 x to the 3/2. So that's going to give me negative 3/2 x to the 3/2 power. And then plus 1/2 x to the negative 1/2 power, all over x squared plus 1. And then I could take, let me circle this, and move that down there. So I would probably write my final answer as negative 3 x to the 3/2 plus x to the 1/2, negative 1/2, over 2 times the quantity x squared plus 1 quantity squared. And there you go.